This is a quick demo of Wodan AI's secure AI software. We developed two comprehensive demos, one in the medical space, one in the financial space, that actually show how encrypted AI work. When we say we encrypt AI, it means end-to-end encryption from the client to the server. The model is running over your encrypted data without ever disclosing your data. So it's unable to leak from the model provider is unable to spy on it and take financial or medical or, God forbid, other use cases with very sensitive data. That data can never leak from your interaction with the model. So let's go straight into breast cancer detection, which is obviously a medical use case. And the first thing we have to do, so we are using a set of breast cancer details, and we are going to talk to the model completely privately. So what we do is we generate a key pair for that. We generate a key pair in 0.7 seconds in this case, that allow us to encrypt our inputs, to then send that input to the model and have the model run over encrypted inputs. So good. Next step, very comprehensive again, is the prediction data that we're going to send over. I'm not a medical expert, but this is all medical information that is sensitive to the patient. So we want to hide the sensitivity from our requests. So what we do is we encrypt our data and we send the encrypted data over to the model. In this case, the model received and inferred the results. So the model evaluated the results. And in order for us to understand what the model concluded, we can decrypt the inferred data. Again, only we can do this. We created at the very beginning a key pair. So we have the private key in our browser. We have the capability of decrypting the result and no one else. That's privacy. Okay, in this unfortunate example, it is a positive result. Now, another thing that is very important in machine learning and AI is accuracy, the metrics of the model. And with encrypting the model and the data, there might be, or there might not, but a difference in accuracy. Now, what we can now do is show the results from the model that was encrypted, and we see the clear model and secure model are 100% accurate. Both have the same accuracy and the same performance. Now, good. This was a medical use case. We have another use case here, which is a time series prediction in the financial services. So what we do is, again, we start with generating keys. We got our keys. So prediction data, we are going to send a couple months worth of revenue over to the server, and then we're going to predict the next month in revenue. So what we do is we send the inferred data to the server, and again, we have results. So only we with the private key can decrypt the results, which is what we do. So we have this data point. How do we know if this data point is correct? Again, we check the accuracy of the model. So if we see the true data and the predicted data, they are not the same. Okay, so prediction is always, so machine learning is always a approximation of the reality. So the reality is this, the approximation was this. So what is very important is that the predicted encrypted data, the cipher data, is on par with the predicted raw data. So let's infer for accuracy, and let's get the true data out so that we have clarity, and we see that the lines for predicted data, raw data, and predicted cipher data match 100% almost. So again, our model is super well performing over encrypted data. We got our key pair. We talked to a model in total privacy. We only with our private key were able to decrypt the data, and the model is 100% accurate and still very good in accuracy and in latency as well. Thank you for checking out our demos.